Well, hello. Today we'll be doing the AQA first topic of the topic particles and radiations. So I'm going to start with a simple understanding of the atom. You have done this topic already in GCSE a lot. So I'm going to just quickly whiz past the things that you've already done and we'll practice some questions on the new things. So let's just get started. So this first thing that you can see on your screen is about the atom. What we know that's inside an atom and how is an atom represented, how is an element represented. So this is a symbol of an element. For example, if I write C, 6 and 12, this 6 here is the atomic number, which also gives the number of protons or the number of electrons. So every element, if it is neutral, will always have and every element is always neutral, so it will always have protons and electrons equal. So number of protons or electrons, and this 12 here is called the mass number, which is the number of both protons and neutrons. So that's about the atomic number and the mass number. Sometimes in the exams they would ask you what's the number of neutrons, what's the number of protons. So directly the smaller number will give you the number of protons or the number of electrons, and to get the number of neutrons, just take away the smaller from the bigger, and that's it. That would give you the number of neutrons, right? So that's your first thing. Now the next thing that comes from here is isotopes. So if you have any element and it has two atoms which have same atomic number and different atomic mass, same atomic number and different atomic mass, it would be known as isotope. So same atomic number, different atomic mass. Now why would it have different atomic mass is because it will have different number of neutrons. So let's just see. So this is just another example of how would you find the number of protons and electrons. So the smaller number, as I just told you, so the smaller number 26 is the number of protons and is also equal to the number of electrons. Here we have done this one, and this would give you, it's a mass number, and mass number helps us to calculate the number of neutrons. When you take away the number of protons from the mass number, you get the number of neutrons. So okay, for your mass 6 is 8, so this is 28, so it has 28 neutrons and 26 protons and 26 electrons. Now so isotopes are the atoms which have same atomic number. So see 1, 1, 1. Now because the atomic numbers are same, that's why it's same hydrogen, hydrogen, hydrogen. So every element is defined by its atomic number. And the mass number is different. That means they have different number of neutrons, as you can see in the picture. Plus means a proton, 1 proton, 1 proton, 1 neutron, 1 proton and 2 neutrons. Same number of electron and same number of protons but different number of neutrons. You know, as the number of neutrons increases in an element, the element becomes more and more unstable. So if an isotope of an atom is unstable, it is because it has more number of neutrons, but that's for the later classes. For now, just understand isotopes are atoms of same element which have same atomic number but different atomic mass. And why is atomic mass different? Is because it has different number of neutrons. Another example is lithium. Say pause and figure out what's the number of neutrons in all of them. If you have done that, So 3 protons, and 3 protons in all of them. So proton numbers is 3, electron number is also 3, but neutron would be different for each of them. 6 minus 3, 7 minus 3, and 8 minus 3. So if you have to guess which one is most unstable, this lithium 8 would be the most unstable because it has the highest number of neutrons. Now the next topic is then ions. Now you've done a lot about ions in both of the sciences in your GCSEs. I'm pretty sure if you're taking chemistry, you know ions are what are ions. But just from the point of view of physics, because we would need something else called specific charge. To understand this, we need to define ion. So you know from your earlier understanding that ion is formed by either gaining or losing electrons. So if you have a positive ion, let's say for example sodium has its atomic number is 11, so it can lose one electron and becomes sodium plus. Now sodium plus is an ion. Now what you need to know in A levels, AQA, is what's the charge on this sodium plus. Now before I go there, know this, that the charge of one electron is 1.6 times 10 to the power minus 19 coulombs. One single electron, presence or absence of one single electron produces this much charge. So my sodium plus ion has a charge of 1.6 10 to the power minus 19 coulombs, positive of course. Now another example is, let's say calcium. Calcium forms 2 plus ion, so it has 2 positive charge. So the charge of calcium 2 plus will be 2 times 1.6 times 10 to the power minus 19 coulombs. So where does it come from? Because the charge of electron is 1.6 times 10 to the power minus 19. Another example, let's say if I take O2 minus. Now this one has a charge of, so because you can see 2 minus, so it'll be negative 2 times 1.6 times 10 to the power minus 19 coulombs, because the charge of an electron is negative. What is this number? This number is just the value of that charge. So if it is a negative charge, you write a minus. If it is a positive charge like calcium or sodium, you don't write that minus. So this is plus, but you don't need to write plus. So plus positive 2 times 1.6 10 to the power minus 19 coulombs. So ions have a particular charge that comes from the number of electrons either it gains or it loses. Now this is something new. So we call this as specific charge. So it's nothing but the ratio of charge divided by the mass. That's it. Okay. Charge is denoted by Q and mass is M. So sometimes Q over M. That's your specific charge. Unit, you of course needs to know the unit. The unit for charge is coulomb and the SI unit for mass is kilograms. So the specific charge is measured in coulombs per kg. So what is specific charge? Nothing but charge divided by mass. Now, a lot of questions are asked on this. Simple ones, not very complicated. But let's just see what kind of questions are asked in your exam. Here you go. This is one of the exam questions. Calculate the specific charge of the argon-37 nucleus. Now, first write down what you need. I need specific charge. And what is specific charge? It is charge divided by mass. Now, the charge comes because of the 18 electrons So 18 times 1.6 10 to the power minus 19, that's a charge of 1 electron, always remember that. And then the mass. Now if I make a model of argon, then inside the nucleus, so this is my nucleus, what does my nucleus has? My nucleus has 37 nucleons, which is 18 protons plus 37 minus 18, so it's 19 neutrons. So now we need the mass of 18 protons and 19 neutrons. So the mass of one proton is 1.67 times 10 to the power minus 27 kg. Actually, to be more, up to 3 significant figures, so this is this. And then mass of one neutron is 1.675 times 10 to the power minus 27 kg. Okay, so this would help us to calculate the mass of the argon 37. Okay, so you don't have to remember all of this data. This data is there in your equation sheets. So let's just do this. So now what I need is a calculator to, so 18 times 1.6. If I'm taking only up to 2 decimal places, I can just write this, plus 19 times 1.6 times 10 to the power minus 27 kg. So now just plugging in the values, you use your calculator to calculate that. I have a mark scheme here. So see, so this will give you the first mark, and then you calculate the charge of the argon nucleus, and then you calculate the mass of the argon nucleus by taking 18 times this, 19 times this, or up to 2 decimal places, because both are same, just timesing 37 with 1.67 10 to the power minus 27. And when you plug into your calculator, this is what the answer comes, coulomb per kg. Let's try another one. A nucleus contains n neutrons and z protons. So I have n neutrons and z protons. Which combination would give the greatest specific charge? Now again, just for the sake of writing, I'm writing specific charge is nothing but charge over mass. Now, which number gives a charge? Z. And which number gives the mass? Both Z plus N. So if I want this to be largest, let's say which ratio gives me the largest one. So let's try with the first one. This is giving me 5 by 11. This is giving me 7 by 15. This is given by 13 by 29. And this is giving me 17 by 37. So you get it. So what I'm doing is I need the ratio of Z upon Z plus N, because mass is given by Z plus N. Okay, now you can use a calculator. I'm going to use mine to see which one is the highest. All right, so let's see. So if doing 5 over 11, I get 0.455. Okay, I'm just doing it as 0.45, sorry, 0.4545. Then 7 divided by 15 is 0.46667. Then I have 13. Just to reduce my rounding error, I'm just taking too many digits for now to see which one, because as you would see, 0.448. See how close the answers are. It is, if you take only up to 1 decimal places, all of them are 0.4. So 0.459. So I want the largest specific charge. So clearly this is my answer. Okay, let's try another one. Okay, you go ahead, pause the video and try to solve it yourself. See what are you getting here. Okay, I'm going to do it assuming that you have paused it and you're checking the answers now. So protons is 20, electrons is also 20, and neutrons is 48 minus 20, that is 28. Is ionized by removing 2 electrons. So obviously the charge of the ion is because of the 2 electrons. So 2 times 1.6 10 to the power minus 19, which is 3.2 10 to the power minus 19 coulombs. Now the specific charge of the ion, specific charge is, I'm just going to do the here, Q over M, charge over mass. Now what's the charge of this ion? The charge is 3.2 10 to the power minus 19, and the mass is because of, now it's entire calcium ion. So the mass, it's not asking for the mass of the ion, charge of the nucleus, it's asking entire calcium ion. So now what is the mass of this calcium ion? It has 18 electrons and it has 48 nucleons. So we need the mass of all of them. Okay, so let's just do. Okay, just telling you here again, your equation sheet has mass of electron is 9.11 10 to the power minus 31 kilograms. So I'm just doing here. So 48 nucleons, that is both protons and neutrons, up to 2 decimal places have same mass. So I'm taking directly 48 times this plus 18 electrons because it has lost 2 out of 20. It has 18 left, times 9.11 times 10 to the power minus 31. That's it. Just divide, plug into your calculator and divide. Let's just see the mark scheme. See here. So we got this, 3 marks. Easy. Can it be easier than this? Does it look like they scare you? A-level physics is so hard. Come on, I don't see it as hard. If you get it, it's not hard. Anything that you don't know is hard, but if you know it, if you understand it, it's not hard. Okay, so we don't write negative sign, because remember, calcium after losing 2 electrons is not a negative ion, it's a positive ion. So it would lose the mark if you write negative. Okay, then specific charge is the charge divided by mass. So mass of the nucleons plus the mass of electrons, and then this. So it's also allowing 1.66 if you are not writing 1.67. Okay, yeah, 67. All right, next. This also, again, you have done a lot in GCSE. It was a 6-marker answer both for physics as well as in chemistry, but still, because it's a part of your A-level physics, I have to go through it. So let's just say, so what is this experiment about? Rutherford, along with few of his lab people, Merson and something, they did this experiment and established the structure of an atom, model of an atom. So what experiment it was? They fired few alpha particles onto a gold foil. Now, before Rutherford, it was assumed that atom is completely filled with positive charge with electrons embedded. So when they were doing this experiment, they were expecting that the alpha particle will bounce back. But to their surprise, they saw that most of the alpha particles went straight. So this was a major eye-opener that, oh my god, we thought that all the alpha particles should be reflected back, but what's going on? So this first led to the first concept or theory or discovery that most of the space inside an atom is empty. What is the reason? The reason is most of the space inside. The reason is because the alpha particle, wait, let me just write, inside is empty, because alpha particles went straight undeflected. That means it should be completely empty. Second, very few, can you see this yellow line? This one is the one that hit the nucleus and came back. This was very, very few. Because very few came back, this showed that the positive is very small at the center. So the positive nucleus, which was named later, is very small. Why was it very small? Because only a very few came back, and then a few were deflected at a large angle. So that showed that mass. Okay, so this showed that the nucleus is positive. Okay, positive mass is centered, is focused, is centered. So the heavy mass is very small. The nucleus is very, very small. So nucleus is positive. How do we know it is positive? Because alpha particle is also positive, and positive repels. So this large angle deflection is because of the repulsion between the positive nucleus and the alpha particle, which is also positive. Right? So that's your Rutherford's model of atom. Now, that's the end of the video, but we're going to end it with an exam question. You're going to pause it and solve it to see what you've learned. And I'm going to solve it assuming that you've done it. So you're going to mark it. A neutral atom of carbon is represented by, okay, so that is missing. I'm just going to write it here. 6C12. Name the constituents of this atom and state how many of each are present. What are the constituents? 6 protons, 6 electrons, and 12 minus 6, 6 neutrons. The constituents are protons, electrons, and neutrons. How many? 6, 6, and 6. Okay, do not leave the short form, write the full form. Okay. Which constituent of an atom has the largest charge to mass ratio? Now, proton, the charge to mass ratio, electron, charge to mass ratio, neutron, charge to mass ratio. Now it's asking which one has the largest charge to mass ratio. This one is 0. Neutron has no charge. Proton, the charge is 1.6 10 to the power minus 19, and this is minus 1.6 10 to the power minus 19. So minus just shows it is negative charge. This doesn't mean it is smaller than 0. Now, which is a heavier particle, proton or electron? Proton is heavier than electron. The mass of electron is this, and the mass of proton is this. So as you can see, minus 27, minus 31. This is smaller. This is bigger. Proton is heavier. Electron is lighter. So charge to mass ratio will be highest for electron, as electron is lightest. But it has the same mass as, it has the same charge as proton. Sorry, my mind went somewhere else. Carbon has several isotopes. Explain the term isotope. What is an isotope? Atoms atoms of same electrons, atoms of same element having same atomic number but different mass number. That's it. Okay, so that's the today's topic, and hopefully we'll do another tomorrow. Till then, keep revising. Thank you.